All right, so taking a look at greatest common factor here, remember we want to find that by looking and finding the largest number that those coefficients have in common, and then find that smallest exponent to find out how many variables they have in common. Once we find that greatest common factor, we will be dividing each term by that GCF to get what was left. So taking a look here at 6, 12, and 21, I can see that they have 1 in common. They have 3 in common as well. Okay, so to find the largest number that they have, that would mean that it would be 3. Okay, and if I look at those variables, the very last term does not have an x, so they do not have an x in common. So that GCF is just 3. So I'm going to write that GCF and then start my parentheses for what is left. So I'm going to divide each of those terms by that GCF of 3. So 6x squared divided by 3 would be 2x squared, minus 12x divided by 3 would be 4x, and 21 divided by 3 would be 7. So here is my final answer. I found that GCF, and then I divided each term by that GCF to get what's left. And remember, to check my answer, I can multiply that back out like we did in the last unit. So 3 times 2x squared is 6x squared. 3 times negative 4x is negative 12x. And 3 times 7 is 21, which that is exactly what the original question said. So I know here that I did correctly factor out that GCF of 3 and divide each term to get what was left. Okay, taking a look at a second problem here. I have 12x cubed minus 8x squared minus 6x. So again, I'm going to find the largest number that those coefficients have in common first. So taking a look at 12, 8, and 6, they have 1 in common, they have 2 in common, okay, and they do not all have 3, they don't all have 4, they don't all have 6, they don't all have 8, and they don't all have 12. So those are the only 2 numbers that they have in common. So that greatest common factor that they have is 2. Okay, but now when I look at all of the terms, I see that they do all have some x's. So now looking at that, I want to find the smallest exponent, and that will tell me how many x's they have in common. So I have an x to the third, x to the second, and an x to the first. So that exponent of 1 is the smallest exponent, meaning that they only have 1 of those in common. So x is included in my GCF. So now that I have my GCF of 2x, I am going to do step 2 here and divide each term by that GCF to get what is left. So I'm going to divide by 2x on each term. Okay, so 12 divided by 2 is 6. 3x to the third divided by x to the first would be x squared. So you subtract those exponents. Remember, when we multiplied, we added. Now we're doing the opposite of multiplying. We're dividing, so we're subtracting. Okay, minus 8 divided by 2 is 4. X squared divided by x, 2 minus 1 would be 1, so there is an x there. And then minus 6 divided by 2 is 3. And x to the first divided by x to the first, 1 minus 1 is 0, so there are no x's left in that term. So here is my answer. I found that GCF of 2x and then factored that out of each term. So I can check my answer here by distributing that 2x. So 2x times 6x squared is 12x to the third. 2x times negative 4x is negative 8x squared. And 2x times negative 3 is negative 6x. And when I look at my original problem, that is what I was given. So then I know that I completely calculated that greatest common factor correctly and divided each term by that. Okay, one more here, looking a little bit more detailed into if there are multiple variables that you have. So again, still wanting to look to find that greatest common factor. So finding the largest number that those coefficients have in common. So looking at 12, 16, and 64, they have quite a few numbers in common. They have 1 in common, 2 in common. They have 4 in common. And they have 8 in common. Okay? So 8 is that largest number that they have in common. Okay, now I want to look at my variables. So remember, we're looking at finding the smallest exponent to determine how many variables they have in common. So I first need to look at the a's. So I have a squared, I have a, and I have a. So they only have 1 in common. That's the lowest exponent. Remember, those are 1s. So they have an a that's getting added to my greatest common factor. Now I want to look at the b's. I have 2, 4, and 3. So the lowest, the smallest would be that exponent of 2. So I'm going to add b squared to my greatest common factor. Okay, so 8ab squared is my greatest common factor. And now I'm going to divide each term by that greatest common factor to get what is left into my parentheses. Okay, so 24 divided by 8 is 3. A squared divided by a to the first would be a. 2 minus 1 is 1, so that's just an a. B squared divided by b squared. 2 minus 2 is 0, so there are no b's to put into that term. So moving on to the second dividing problem. 16 divided by 8 is 2. A divided by a, 1 minus 1 is 0. There's no a's there. B to the fourth divided by b squared would be 4 minus 2 is 2, so b squared is still left there. And then plus 64 divided by 8 is 8. And a divided by a, 1 minus 1 is 0. There's no a's left. And then b to the third divided by b squared, 3 minus 2 is 1. So there's 1b left in that answer. So here's my final answer once I have divided by that greatest common factor. And again, if you're wondering if you have that right answer, remember you can distribute that back out and see if it gives you the original problem that you were given.